Now, just to recap, last time we found that if a series is written, a geometric series is A, which is the first term, plus AR plus AR squared plus until AR power of n minus 1, which is the nth term. Then this sum is equal to A times R power of n minus 1 over R minus 1, which can be also, if we time both the numerator and denominator by minus 1 minus R power of n over 1 minus R. Right, so for example, if we have a series which say is Sn is equal to, say, our first term is 1, and then we are going to say, well, R is 2. So, okay, so that would be, then the second term would be 2, and then the third term would be 4, and then the fourth term would be 8, and so on. So if we continue that indefinitely, well, clearly that would tend towards plus infinity because these numbers here keep increasing. So what we say is that in that case we say the series diverges. Yes. However, if we have a theory where R is equal to 1/2, and so the series would be Sn, and say the first term is 1, so that would be 1/2 plus 1/4 plus 1/8 plus . Well, what does it tend towards? Does it tend towards something or not? Well, okay. So, so what we say is that this is basically, what we can say is that this is the limit when n tends towards plus infinity of the sum above, which is A, well, it's actually A times 1 minus R power of n over 1 minus R. And what we can do is we can substitute A by 1, which is the first term. And, well, yeah, so actually it simplifies a bit. Let's simplify that. Let's rewrite it all together. 1 minus R power of n over 1 minus R, because in that case, A is equal to 1. Right, so what does it tend towards? Well, here R is a value which is less than 1, because it's actually, in that case, it's 1/2. So a number less than 1 power of n which tend towards plus infinity, well, that means that all of this quantity here is going to tend towards 0. So the limit, and then R is a constant, it's 1/2, so that means that the limit is going to be 1 over 1 minus 1/2 in that case. So it's going to be 1 over 1 minus 1/2, that's 1/2, so it's going to be 2. So that means that this infinite series tends towards 2. And in that case, we say the series converges because it tends towards a finite limit, which in that case is 2. So what is the criteria for a series to diverge or converge? Well, if the absolute value of R is greater than 1, strictly, the series diverges, as we showed above. If the absolute value of R is actually or equal to 1, is less than 1, then the series converges. Right. And what is this limit? In that case, the limit, say the absolute, the infinite value of the sum of this infinite sum of terms is equal to 1 over 1 minus r. Formula which is in the formula sheet, except basically they don't say the infinite here, they just say s, I think. So, right. And this all only apply, of course, when the absolute value of r is less than 1. Not that it applies if r could be negative. So r, for example, could be minus 1/2 or minus 1/3. Let's do an example. Say, okay. Say, well, we have an inf value which is, say it starts at 2, well, for a bit of a change, plus 2 times minus 1/3, plus 2 times minus 1/3 square, plus infinitely. What is the ultimate sum? This sum, okay, well, we apply the formula, so it's a times 1 over 1 minus r, so that's an a in that case is 2. So that means that, yes, actually I made a mistake here. This is not 1 over 1 minus r. This is a over 1 minus r. So s is equal to, so 2 over 1 minus 1/3. So it's going to be 1 minus 1/3, so it's going to be 4/3. So it's going to be 6 over 4, which is 3 over 2. 1.5. Yes. Yes. That's pretty much it.